Hello, Mr. Claudia here. Today we're going to continue our review of functions. We're going to spend today just looking at quadratic functions. Now you've spent 2 courses looking at quadratic functions, so most of today is review. I've tried to give you one page that summarizes everything that you need to know about quadratics because quadratics, even though we learned it in grade 10, it is part of the IB curriculum. So there will be an IB exam question that will be on quadratics, which is great news for you because you've spent a lot of time in it, you're very comfortable with it. So consider this a review of everything. I'm going to try to go quickly through the stuff that's easier, and I have some more difficult problems on the back, so at least you'll get something new out of this this lesson. So quadratics, they're a member of the polynomial family. We have the linear, if you remember, we have linear functions, which are lines. We learned that in grade 9. Then we have quadratics, which have a square. Then if we have a cube involved, that would be a cubic function that has this shape, 4th order, and we could continue. Really, this is one where we're going to learn a lot of tricks so that we can do things with quadratics without calculus. When we get to the cubics, 4th order, we're going to teach you things in calculus that allow you to deal with any polynomial. But for quadratics, we have a lot of tricks that allow us to shortcut the calculus. Okay, so there are 3 ways that we can write the quadratic functions. The first one, standard form, y equals ax squared plus bx plus c. Why is this a useful version? Well, first of all, the a tells us the direction of opening. We'll see that in the other 2 forms as well. And a little known formula that you probably don't use a lot, but is on your formula sheet, is we can find the axis of symmetry from standard form. X is equal to negative b over 2a. That's a little trick. You probably learned it last year, but you didn't even bother using it. You forgot about it. But this is a useful formula, as we'll see later today. So this is standard form. There's not much you get out of it. But we can go from standard form to factored form by factoring this. You would have spent an entire week learning how to factor last year. All the different types of factoring, you still have nightmares of it. But when you get to factored form, we have a lot more information. In factored form, we can tell you right away what the zeros of the quadratic are, so where it crosses the x-axis. It crosses at P and at Q. Again, we have this a value that tells us the direction of opening. Positive opens up, negative opens down. Go back to standard form. Another thing we can do with standard form is we can move to vertex form. We do that by completing the square. We'll do an example of completing the square later so that you jog your memory. But once we get to vertex form, again, this is a much more useful form than standard form, because this tells me the vertex. The vertex is h, k, so it's the negative of whatever number is here, that's the x value, and this is the y value of the vertex. Again, this letter a, or this number in front, the a, is the direction of opening. To go from vertex to standard form, you have to expand, so you could expand this by foiling, and you could go back to standard form. Similarly, factored form, if you were to expand it, if you were to FOIL it, you could go back to standard form. So this is kind of my road map of all the different forms of the quadratic. Again, you've done this before, hopefully it's review. Now, when you graph a quadratic, there are a bunch of different points that we're at different parts of the quadratic we want to be familiar with. So there's my quadratic. This is opening down, or I'd call it concave down. We want to get used to that terminology, concave down. Think of it as the cave part of it faces down. Or maybe you're really good with lenses in science, concave lens. Okay, we have our axis of symmetry, so that's the mirror point that reflects the symmetry of the quadratic. We have the vertex, that's the max or min point. We have the y-intercept where we cross the y-axis. We have the x-intercept where we cross the x-axis. Some other terms you might hear in IB is or in any math class, we might call the x-intercepts also the 0, or aka means also known as. or we call it the root. So x-intercept, 0, root, they all mean the same thing. The vertex, in this case, we would call it, it could also be called the maximum, or something you might hear in IB, not so much in other classes, is the turning point. So the vertex is the turning point. Another type of quadratic would be one that opens up. In this case, it'd be concave up, and it has a lot of the same points. We're not going to spend too much time with this. You should know how to graph a vertex, a parabola in vertex form or a parabola in factored form. But let's try doing one like this. Let's do one example at least. Determine the quadratic equation for the following graph. Wow, I don't have a lot of information here. I know that the axis of symmetry is x equals 3. I know it goes through this point 2, and I know it goes through this point 12. Which of the three forms make the most sense here? Well, standard form we know doesn't tell me much. Vertex form, well, I don't really know the vertex here. So I'm going to go with factored form. So right off the bat, I know that my form that I'm looking for is y equals a x minus p x minus q. I mean, I just need to figure out these three numbers, a, p, and q, and I'm done. Okay, so I know that these p and q corresponds to my zeros. Well, there are zeros at 2, 0. That's one of my zeros. And do I know my other zero? It's not marked here, but I do know it. Because of symmetry, if this 0 is 1 unit away from the axis of symmetry, that's x equals 3, then this 0 must also be 1 unit away. So it would be 1 greater than 3, so it would be 4. So I'm just going to put in brackets there, that's due to symmetry. So we still have to keep our brains working when we deal with quadratics. So now that I know these two zeros, I can rewrite my vertex form, y equals a x minus 2 x minus 4. Now I'm happy because I have these two numbers, but I'm sad because I still don't know what a is. I need some more information. Do I know anything else? Oh yes, I know this point here. So I'm going to sub in another point. The y-intercept, 0, 12, right? 0 over 12 up. So when I sub in those values, I get 12 is equal to a, 0 minus 2, 0 minus 4. This gives me 12 is equal to a, negative 2, negative 4. 12 is equal to 8a. So a is equal to 12 over 8. I can divide top and bottom by 4. That gives me 3 over 2. Therefore, y is equal to 3 over 2, x minus 2, x minus 4. So I was able to find the quadratic equation of this line, of this parabola, using this strategy. Okay. So, in a lot of cases, we're going to discuss how a function works, what it looks like, and then how to solve equations involving that function. So here I have an equation, a quadratic equation. Call it an equation because there's an equal sign in it. And one skill we want to learn in all math is how do I solve this equation? In other words, what x value makes this expression true? Now, when we have linear equations, they're very easy to solve. You just use your BEDMAS backwards skills and you can solve for x. But solving a quadratic is harder. You can't just undo BEDMAS here. There are two ways you can solve a quadratic equation. The first is factoring, and that's why you spent a week factoring when you learned this last year. There are a lot of different ways you can factor. I mean, this is a tougher trinomial because you have a coefficient here. You might write out all of the factors, the two things that multiply to this and add to this. I try to, especially if it's small numbers like this, can I do this on my own? Like, can I do this without doing too much hard work? I know that to get 2x squared, I need a 2x somewhere, and I need an x here, right? 2x times x gives me 2x squared. I know that to get 3, the only way I can get 3 is 1 times 3. So I can either put the 1 here or the 3 here. So if I put the 3 here, I get 3 and I get 2. But then they need to give me a sign of negative 3. So I believe I put 1 here, 3 here. So 1 has to be positive, 1 has to be negative. Well, 2x times 3, if I put a negative here, that gives me negative 6x. If I put a positive here, that adds 1 to give me negative 5x. And 1 times negative 3 gives me negative 3. You can use whatever strategy you like for factoring. I like to do it by inspection if possible. So now that I've factored, again, the question was, what x value makes this statement true? Well, for this to be true, either 2x plus 1 is equal to 0 or x minus 3 equals 0. This is the beauty of factoring a quadratic. When I have it in factored mode, or factored form, well, anything times 0 will give me a 0. So if this is a 0, this whole expression will be equal to 0. Or if this is a 0, this whole expression will be equal to 0. So now I just need to solve these these two linear equations. 2x is equal to negative 1, x is equal to negative half, or x is equal to 3. This is how you solve a quadratic. Now, if you can't factor it, this is very difficult, big numbers, or some quadratics cannot be factored, one method that will always work is the quadratic formula. The quadratic formula is technically using a long method of completing the square, but what we've done is completed the square and created this formula that always works. The quadratic formula is on your formula sheet, but by this point you should know it off the top of your head. If I may sing my song, it's x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, and now I just, as you would have done last year, I'm going to sub in my numbers. So if you weren't able to factor this, quadratic formula always works. So this is my b value, negative 5. So the negative of that, negative of negative 5, plus or minus the square root of negative 5 squared minus 4 times the a value, which is 2, times the c value, which is negative 3, 2 times 2. We don't like the quadratic formula, it's a lot of work. Negative 5, so that's 5 plus or minus square root of 25. This is going to be 12, 24 negative, so plus 24 over 4. Closing in here, this is 5 plus or minus the square root of 49 over 4. This is 5 plus or minus the square root of 49, which is 7 over 4. Okay, so 5 plus 7, well, let's show you that. 5 plus 7 over 4, or 5 minus 7 over 4. So that's 12 divided by 4, which is 3, or negative 2 over 4, which is negative half. So you get the same answer. It's a lot longer process to do that. A large part of IB is going to be your time management on the exam. So note the time that was wasted here. But we still got the right answer. Phew, okay. This next little section is something that just want you to keep in mind in terms of solving equations. If I were to give you this equation, x squared equals 5x, how do you solve it? How do you figure out what value of x makes this true? Well, your first impression might be to, okay, well, let me divide both sides by x. That gives me x is equal to 5. You can test your number, right? 5 squared is 25, 5 times 5 is 12. Oh, it works. That's the correct answer. What about this question over here, x squared minus 5x? How would you solve this? Well, when you look at it like this, quadratic, I solve by factoring. And this is an easy factoring. Factor out the x, and I'm left with x minus 5 is equal to 0. Well, now I know my two answers. This statement is true if x is equal to 0 or x is equal to 5. This question has two answers. Look carefully at these two problems I gave you. They're actually the same thing. This is x squared. If I brought the 5x to the other side, it would be x squared minus 5x equals 0, which is exactly what I wrote here. So when I solved it this way, I only had one solution. When I solved it this way, I had two solutions. Technically, I've missed the solution here. This is the correct answer. I had one of the correct answers here, but I missed the x equals 0. The reason for that, by dividing by x, we lose information. This is a quadratic expression. Whether you like it or not, it has x to the power of 2 here. So it's quadratic, and there should usually be two solutions to it. So when you get x equals 5, the alarm bell should be going off. What about the other answer? What about the other half of my parabola? When you are given a quadratic or any higher order polynomial, you should solve that equation by factoring. So set it equal to 0, factor the other side, and then all of your factors, set them equal to 0, and that'll give you your answers. So that's just a kind of discussion about solving equations. One thing you would have learned in previous course is the discriminant. Now the IB program really likes to give questions about the discriminant, which is good. They're not too challenging. The discriminant, again, this is a formula on your formula sheet, goes by this big triangle. The discriminant is the part of the quadratic formula underneath the square root sign. If you remember when you learned about the discriminant, you can't take the square root of a negative. So if the discriminant, if this expression is negative, you have an impossible situation and you have no real solution. If the discriminant is 0, you end up with only one solution, and if the discriminant is positive, you get two solutions. That's illustrated graphically here. If the discriminant is 0, there's only one root or one real solution. Discriminant's greater than 0, so it's a positive value. You get a situation where the parabola crosses the x-axis twice, so you have two solutions. And if you have a discriminant negative, you have an impossible situation, so you actually have no solution, or no real solution, we would say. You might have a complex solution, but that's beyond us right now. We would just say no real solution. So I don't have any room for any questions on this, but there is some in the homework. And you've done this before, so it should be a review. What I'd like to do now is a few more difficult questions, 2 word problems, one which is inequalities. Hopefully you've done inequalities in a previous course. If you haven't, well, we're going to do it now. So let's do, we'll call this, this 1.1c, page 3. So we have inequality. Okay, so solve the inequality x squared minus 6x plus 8. Now an inequality means it's not equal, right? There's no equal sign. But to solve it, we're essentially going to use the same strategy we would have if there was an equal sign. That is, I'm going to factor it. So I have x. What two numbers multiply to 8? Well, 8 and 1, probably 4 and 2, though, I think would work out better. Does that work? Yes, it does. So what we want to think for this question is imagine the parabola. Let's do a quick sketch. We have a intercept at 2 and at 4, and it opens up, so it's going to be something like that. Now, the question is saying, when is this parabola smaller than 0? So we're really interested in the section that's smaller than 0. Well, I can tell you by looking at it, this parabola is smaller than 0 for this section here. So I'm going to write, imagine the parabola, think, when is x squared minus 6x plus 8 when is the parabola less than 0? And that happens at this portion here. So I would say that this is true when x is a value that's either, I think this is 2 and this is 4, so when x is between 2 and 4. X is between 2 and 4. Remember I said to get used to that form. X is greater than 2, x is less than 4. What about equal to 2? Well, when x is equal to 2, you're actually on the line, you're on the x-axis, and you are not technically less than 0, you're equal to 0. So actually the answer is yes, just greater than 2 or just less than 4. No equal to. Okay, let's look at the second example. This is my easy word problem. Okay, what is it? The profit in manufacturing X refrigerators per day is given by this profit relation. This is a question for all our CEOs, future CEOs out there. How do I maximize, how many refrigerators should be made each day to maximize the total profit? What is the maximum profit? So you can imagine there's a certain number of refrigerators. You make too few, you're not making enough profit. You make too many, you're not making enough profit. There's a sweet spot. And I know just by looking at this that it is a quadratic that's opening down. So I know there's some sort of max point. Let me make a quick sketch actually to help me understand that. So I have the number of refrigerators. Oh, you can't see any of that. There we go. So the number of refrigerators, and then I'm looking at my profit. Sorry, that's my problem, right? X is the number of refrigerators, and P is my profit. Okay, so we know this is some sort of quadratic equation. I have no idea, but I know it opens. Remember, standard form isn't very useful, but I know it opens down. So let me just draw something like that, right? It's just to help me understand what's going on here. So there's some profit point XP that I want to know. Okay, so how do I figure out this point? Well, I mean, this is a vertex point. So essentially what I'm asking you to do, and if we go back to my roadmap here, I've given you standard form, which isn't very useful, and I'm asking you for the vertex. So what you could do is find vertex form by completing the square. So I'm going to call that method 1. Complete the square. In other words, find vertex form. Okay, so let's start with my function, which is p is equal to negative 3x squared plus 240x minus 800. Okay, there we go. Let's see if you remember how to complete the square. The first thing you do when you complete the square is you're looking at the first two terms. You have to divide out, because we have this a value, you have to divide out the negative 3. you're left with x squared. What's 80, or 240 divided by 3? That's 80. Oh, negative 3 is minus 80x. Then what I always teach my students to do is leave a space and then subtract 800. Okay, now I have to figure out what can I add and subtract here to make the square. So the way to figure out the number that you add and subtract is you take your b value, your 80 here, and you divide by 2, and then you square it. So if I go off to the side, I have 80 divided by 2 is 40. 40 squared is 1600. So negative 3 x squared minus 80x. So I'm going to add 1600, subtract 1600. Again, how did I do that? I took 80, divided it in half, and then squared it. What I'm trying to do here is create a perfect square. And so that's kind of my strategy for doing it. Now, I can't factor my perfect square with this extra thing here, this negative 1600. So I need to move the negative 1600 out of the bracket here, out of the exclusive club. To do that, I multiply it by 3. So I end up with p is equal to negative 3x squared minus 80x plus 1600 minus 6, so this is going to be plus 4800 minus 800. Okay, and now I can complete the square finally. So the hard part is over. Negative 3 stays here. I need to factor this perfect square. I end up with x minus 40. It always will be the second term divided in half. If you don't believe me, you can test it out, right? 40 times 40, negative 40 times negative 40 gives me 1600. Negative 40 and another negative 40 gives me the negative 80. And then outside the bracket, I have 4800 minus 800, so that gives me plus 4000. Now, miraculously, I have emerged in vertex form. You can read right from this. The vertex is, remember I take the negative of what's in the bracket, so it's just going to be positive 40, 40,000. That hasn't solved my problem yet. Oh wait, the x value is the number of refrigerators, the y value is the profit. So therefore, max profit is $4,000. It occurs at 40 refrigerators. Neat. So our first method, we look to complete the square to find vertex form, because in vertex form I have the information about this max point. Neat. Annoying though. We don't like completing the square. It's a lot of work, but it is in the IB syllabus, and you could be asked to do it. Let me show you another way that you could do this. Method 2. Find the axis of symmetry. And I told you, this is a oft-forgotten thing from quadratic unit, but it is a formula on our formula sheet. The axis of symmetry is, we can figure it out in standard form by using this formula. X is equal to negative b over 2a. This formula, I won't go into where it comes from, but it kind of looks familiar. It has some, reminds us a bit of the quadratic formula, and it reminds us a bit of what we did here. I took the b value, divided it by 2. It kind of has a little bit of, kind of makes sense. Regardless, I can use this formula. X is equal to negative 2b over 2a to find the axis of symmetry. The b value was 240, so I'm going to have negative 240 over 2 times a, which is negative 3. That gives me negative 240 over negative 6. 6 goes into 24, so that gives me 40. So I know now that the axis of symmetry occurs at, is x equals 40. Now, to find the corresponding y value when x is equal to 40, well, I will just sub x back into my original equation. So then sub x equals 40 into p at x. So p at 40, that is equal to negative 3 times 40 squared plus 240 times 40 minus 800. And if I do some math, I'll find that p at 40 is equal to 4,000, which is the same answer. Which method is right? Well, they're both valid. They're both, there's many different ways of analyzing quadratics, and they both work. This one might be something that's more reliable because you're able to remember that roadmap I gave you, right? To get the vertex, I just need to get the vertex form. But don't discount this very handy formula. It's often forgotten, but it's very useful because it can quickly, there's a lot less work happening in this solution. There is actually a third solution. And that is calculus. Finding the max point of a curve is a textbook calculus problem. But you don't know calculus right now, so you have to rely on these tricks we've learned about quadratics. On your IB exam, you'll have calculus questions and you'll have quadratic questions. It's not worth it to apply the calculus here if it's going to be time consuming. It might be more effective to use your quadratic tricks. But when we get to calculus, you'll see that we can do this same problem using a whole new method of solution. To be continued. Okay, our final question is, let me get this, is this difficult word problem. So this is going to be 1.1c page 4, and we're going to call it the difficult word problem. You can see everyone is very nervous with the word difficult in front. It's difficult because there's no formula given, and I know in previous years I get a lot of stressed out students because I haven't given you the formula here. We're going to spend a lot of time looking at word problems when we get to calculus and how to solve word problems and how to model word problems. So I don't want to go too in-depth into word problems today because this is just a review of quadratics. But I'm going to do one with you and give you a few for homework, just to give you a taste and to try to remind you that questions like this will happen. But please don't be too overwhelmed by some of the word problems you're going to see here. The emphasis is on quadratics. A rancher plans to use 120 millimeters of fencing to build a rectangular pen. Let x represent the width of the pen. Find the length and area of the pen in terms of x. Now you might be reading that and already be a little overwhelmed. Sometimes I find the same thing, but what helps me the most when I'm doing any word problem is to draw a picture. So I have a rancher, and he wants to build a rectangular pen. Okay, well that I can work with. There's my rectangular pen. I don't know anything about it. There's my rancher. Maybe the rancher has a pitchfork. He's probably working with hay. And maybe he has a dog too. Okay, so now we know x is going to be the width of the pen, so I'm going to call this x, the width. And then I'm going to call this, I guess, the length. Why don't we call it, what do you want to call it, y for now? Let's let y represent the length. Okay, so the question is saying, find the length and area of the pen in terms of x. Okay, so the length of the pen is, well, it doesn't have anything to do with width. Let's go back to the question. A rancher plans to use 120 millimeters of fencing. Oh, interesting. Well, we know that then this guy and his dog are building a pen that this plus this plus this plus this is going to be 120. So I know that perimeter, it's going to be 120 is equal to x plus y plus y. I can join some things together, so I get 2x plus 2y. So remember what the question was asking. Find the length of the pen in terms of x. Well, my length is y, so I'm going to rewrite this to get y by itself. That's going to be 120 minus 2x is equal to 2y. I'm going to divide both sides by 2, so I get y is equal to 60 minus x. So look what I've done. I've rewrote the length in terms of x. To find the area, well, area is a little bit easier. Area of this pen is going to be length times width, so that's going to be x times y. But they want to know the area in terms of x, so I got to get rid of this y. How do I get rid of the y? Well, I have an expression now, so I'm going to sub in y equals 60 minus x. So I get my area is equal to x times 60 minus x. Area is equal to 60x minus x squared. So what makes this question a difficult question? I say it's because you have to do this modeling, and this is mathematical modeling, where you create the equation on your own. Look how I've created a quadratic equation. As I said, this might be difficult. You might not have done this last year. You might not have figured it out last year. You might have forgotten. Don't be too overwhelmed by this. Try some of the homework problems. We're going to spend a lot of time doing this when we get to calculus. So for now, don't focus more on the quadratic aspect here. Part B, find the dimension of the pen if the area is 800. Okay, well, that means I'm going to set area is equal to 800. Oops, can't see anything. Fortunately, I have a great formula here. So I have 800 is equal to 60 minus x squared. Oh boy, I wrote that wrong. 60x minus x squared. Now remember, we talked about this in the lesson. I need to solve this expression for x. I have to figure out what x is. If this was a linear expression, it'd be really easy. I would just use BEDMAS backwards, but it's quadratic. The only way to solve a quadratic is by factoring. So let me bring this all to the same side. So I have x squared minus 60x plus 800 equals 0. Solve by factoring. Can you factor this in your head? If not, you can always use the quadratic formula. I know this has to be x and this has to be x. I know to get a positive and a negative here, these both have to be negative. What two numbers multiply to 8? Well, to 80 really. So 40 and 20, I think. So I could put minus 40 minus 20. Does that work out? 20, 40 gives me 60. Yep, works out. So I've just factored it. That's my solution method. What was my question? The dimensions. So therefore, x equals 40 and x equals 20. What does that mean? That means for this area to be 800, I have to have a width of 40, x is equal to 40, or a width of 20. The corresponding length is, I have to subtract 60 from 60. So therefore, the dimensions are 40 and 60 minus 40 equals 20, or 20 and 60 minus 20 equals 40. So it's basically a 40 by 20. Whoops, oh boy, sorry. So it's either, the dimensions are either 40 and 20, 40 by 20 size, or 20 by 40. Those are two options. Part C. We want to find the maximum possible area of the pen. Well, if this is my formula for area, I could rewrite it as in more recognizable form. Again, if you can imagine this, this is some sort of quadratic that opens down. and I want to find out what the vertex. This is just like that last problem. How do I find the vertex? I think it's pretty easy to use that strategy I taught you in the last example. So find the axis of symmetry. So x is equal to negative b over 2a. That's a formula on your formula sheet. B in this case is 60, so I have negative 60 over 2 times negative 1. That gives me negative 60 over negative 2, which gives me 30. Therefore, the max area occurs with width 30 and length. Remember, to find the length, I just subtract my value from x, or from 60. So I get 60 minus 30, which gives me 30. So a 30 by 30 pen will be my maximized area. I hope you were able to follow that difficult problem. Again, it might be something new from last year. At least we had some challenge today on this big review of quadratics. Your homework for tonight is... Okay, gonna write it down here. So your homework, we have a few things. Page 56, number 1 to 7. Page 55, number 1, 2, 6, 8. These are the word problems. Oops. Please attempt them. I only gave you ones I think should be accessible. You can try all of them if you wish, but don't be overwhelmed by the word problems. And finally, inequalities. Now, our textbook doesn't have a lot on inequalities, so I'm going to give you 3. Solve 3x squared plus 5x minus 2 is greater than or equal to 0. X squared minus 5 is less than or equal to 0, and 2x squared plus 6x minus 6 is less than x squared plus 2x. I'll write the answers next to this, and you can check on the scan. But that's just some practice on inequalities to make sure you're comfortable with them. That is our big review of quadratics. I hope it was enjoyable. Good luck with the homework, and we'll see you next time.